Hi everyone, in this video we are going to explore the second type of nonlinear equation, which is what we call a parabola. And a parabola is when we are going to see x squared in our equation. So if we think about y equals x squared, I want us to think about what if I plug in these values for x, what are they going to output for y? So remember that if I plug in -2 for x, that means I'm saying -2 squared, which is going to get me to +4. This would be -1 squared, which gets me to +1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. Notice here, this is really important. Notice here when I have my negative symbols, right, my negative integers, I am including them inside the parentheses. That's really important to remember. I could also always go include the parentheses down here. They're just not as important. So remember, these are all coordinates that I can now graph on my coordinate plane. Should then turn out like this. So when I go and graph this point, you're going to notice that a parabola actually has what we call a U shape. Okay, it's curvy. Unlike our absolute value, which was very perfect rigid V or mountain, our parabolas are what we call kind of smiles or frowns because they're curvy. The other thing I want to point out is notice that they have another perfect line of symmetry. And do you notice too my points here, right? So if I look at this point and this point, they are both equidistant from, again, this is our vertex, right? Remember that word? Our vertex is 0, 0. Those 2 points that I just drew, this is -2, 4. So I've gone back 2 and up 4. And over here, I have +2, 4. So they're both 2 away and 4 up. The same would be true about these points. So there's that vertical symmetry happening all the way up your U. So our vertex form for a parabola is very similar to the vertex form that we had for an absolute value equation. Remember our y and x, or x and y, I should say, are coordinates on the line or on the parabola. Remember that our a value, that's going to tell us, does it open up or down, so a smile or frown, and is it wide or skinny? And then last but not least, remember our vertex here is that h comma k value. So hopefully this feels familiar. It's just a little different that now I have a curvy situation. Okay, so here, let's try graphing this one. Hopefully you can quickly identify here that my vertex is going to be 4, 5. Now again, similar to last time, I want to pick a point before 4 and after 4. So I'm going to pick the number 2 and I'm going to pick the number 5. So if I plug in 2, I'm going to say y equals 2 minus 4 squared plus 5. When I do this math, 2 minus 4 is -2. I need to square that and then add 5. 2 squared is going to be 4. 4 plus 5 gets me to +9. All right, now let's go back. And now we're going to plug in the other number that I chose, which is +5. So I'm going to say y equals, I'm going to do 5 instead of x, minus 4 squared plus 5. 5 minus 4 is 1 squared plus 5. 1 squared is 1. 1 plus 5 is going to get me to 6. When I graph these points, it ends up like this. Now, this doesn't really look like a graph, right? This is tricky. So what I want to think about is I want to know, okay, this is my vertex, right? That was my 4, 5. So I want to think about my line of symmetry. Well, if my line of symmetry goes like this, right? I can think, well, the replica of that point is going to be over here, right? And the replica of this point is going to be over here, right? Because they're the same distance from my line of symmetry. Now I have a nice U shape. Okay, again, my vertex right here is that 4, 5 that I see. My A value here is 1, which is going to tell me that it's opening up as a smile. All right, let's try another one. Hopefully you see here that my vertex is really nicely -3, -2. I'm going to choose the point -5 before that and the point 0 afterwards. So I'm going to do my work down here. So if I say y equals -5 plus 3 squared minus 2, -5 plus 3 is going to get me to -2 squared minus 2. That's going to be Negative 2 squared is 4, so 4 minus 2 is going to get me to a value of 2. Okay, let's try that again, now with plugging 0 in for x. So y equals 0 plus 3 squared minus 2. That's just going to leave me with 3 squared minus 2, which is 9 minus 2, which gets me to 7. So when I plot those points, it's going to look like this. Remember, my vertex is right here. So I can think about my line of symmetry. Okay, and I want to replicate, let's see, this point, it's 2 away from my line of symmetry, so I can do this here. This point is 3 away from my line of symmetry, so I can do this point here. Now, I can graph my nice parabola. It's not perfect, but you get the idea, and there's my u. And again, here's my vertex down at negative 3, comma negative 2. Now, one option you could do, of course, is when you're building your t-chart and you have your vertex of negative 3, negative 2, you could, of course, just pick points that are automatically on either side of it, right? If I pick negative 5, comma 2, I know that just as I graphed right here, this is also going to be negative 1, comma 2. So you can also do it that way, or you can pick and choose points and kind of plot the symmetry. All right, so I want you to pause the video here, and I want you to try to graph this one on your own. Okay, you're back. So hopefully you saw your vertex here was 3, comma 5. I picked a couple points before and after. But again, let's think about this line of symmetry right here all the way down. If I want to replicate this point, it's 1 away, so it's going to be right here. If I want to replicate this point, it's 2 away, so I'm going to go 2 on the other side. And now here's my nice parabola. Whoop. Okay, you can see my A value here is negative 2, which is why we see we're frowning. Also notice that that negative 2, that's a larger number. Well, I guess technically smaller with negative, right? But the absolute value of that would be larger. And that's why it's getting a little skinnier. Okay, and then here, of course, is our vertex of 3, comma 5. All right, one more. Try this one on your own. Okay, you're back. So hopefully you found a vertex of negative 2, comma 0, right? Because there I could add a plus 0 right here. So negative 2, comma 0, which is this point right here. Again, my line of symmetry is going to look about there. If I want to replicate this point that's at negative 4, I'm going to go 2 to the other side. And if I want to replicate this point at 2, 8, it's, let's see, 1, 2, 3, 4. So I would go 1, 2, 3, 4 over here. And then I can draw my parabola. It's a little bit like a V, but it should be a U. And let's try that again. You can see that this here, oh boy, this here is a little wider this time, again, because of this A value being 1/2. It ends up being a little wider. So that's parabolas. So now you've learned absolute value and parabolas. A lot, of course, there are a lot of similarities, but remember the difference between the V versus the U, the mountain and valley, and the smile and frown. Hopefully this all makes sense. Bring your questions to class, and good luck with your work.